Just a quick description to explain to you about the OM70, what the lights mean on the top here. So the first light here is the switching output light. So when we've set up our digital switch, you'll see this go on and off. The alarm output light goes on and off. There's a problem, or the measuring position is either too far or too close, so it's not seeing anything. And then our power link light, when it's flashing in blue here, means that it's connected via the web server or via the Ethernet TCP IP. If I disconnect here now, you can see it's getting power, but it's not connected via Ethernet. If I reconnect again, you'll see that it starts blinking again. Hi, so just a quick video to demonstrate the capabilities of Baumer's OM70 Webserver laser distance laser gauging sensor. So the model that we're looking at here today is the OM70 line beam 250mm sensing range, the sweet spot 240mm, and the EK here on the part number indicating that it's the web server version of the sensor. So in its description, yes, it's got a range of 50mm to 250mm, so a total measuring range of 200mm. The sweet spot for the beam spot is 240mm. I've got the sensor currently here set up at 250mm away, and the line beam spot, as you can see here, is not a pinpoint, it's a line spot, and it can be seen there. Okay, so yes, the sensor has a resolution of down to 1.4 of a micron and a repeat accuracy of 0.3 micron at its best. So yes, a line beam, a laser class 1 sensor. It's got digital and analog outputs, 4 to 20 milliamp, 2 to 10 milliamp, 0 to 10 volts and 0 to 5 volts selectable via the analog output wire, and the switching output is push-pull. In terms of if you're going to use it outside of the setup for its web capabilities, you can use Ethernet TCP IP interface and the protocols of Profinet, Modbus TCP, OPC UA and UTP streaming, selectable as to which you prefer. And no software required, it's a web server version, so all you need to do is input the IP address of the sensor, which of course you can select the address as you require. Just a bit of information about the physical size of the sensor, and of course the shock and vibration it can deal with, and also the IP rating and temperature operating capabilities. On the web, of course, you can download the datasheet, the manual, and also, if you require, the GSDML file for PLC setup, and also you've got the 3D CAD drawings of the sensor there. And so you can see the characteristics of the beam spot. At its closest range, the line beam is 1.6mm in width, at 240mm at 2.2mm, and then at its maximum range 250mm, again 2.2mm. Okay, so let's now go into the web server. So all we do is type in the IP address of the sensor. The standard one out of the box is 192.168.0.250, and you can see automatically you get a measurement output. It's currently measuring where I've set up the sensor here around 250mm away from the table there, and you can see the exposure reserve. So this is the amount of exposure we have remaining before the sensor starts to struggle to measure. Also the response delay on the output, and also the measuring rate here in hertz. So this graph is just showing us the distance over time, and we can set the time period to whichever we wish, even down to a few seconds here. And this is results over time. So if I just introduce some brighter targets, you can see a nice white card here. You can see we have a huge amount of exposure reserve. If I now introduce a darker target, something like so, you can see that the exposure reserve is again reduced. The minimum exposure reserve that we can deal with is down to 2 units. So you can see something that's even very dark, there's no real issue with that. Okay, let's go back to our tabletop again. So we can go into the setup of the sensor just by clicking the parameterization tab here. Click OK, and now it allows us to access the other bits of information and the easy setup of the sensor. So in terms of how do we want to receive the measurement information, or how we want the sensor to measure. Free running means it's constantly measuring and giving us an output, or you can ask the sensor to trigger every set time period and you can just type in the value there, or a single shot and you trigger it just like you would, say, something like a camera. Next, we can set up the measuring range of the sensor. So out of the box, this particular sensor does 50 to 250 mil. We can change that by moving our bars up and down. You can see the values have changed here. Or you can physically type in the values that you wish. So if you only want to measure an item between, say, 150 mil to 220 mil, for example, it does that. And there's nothing in the current field of view there, so it's giving us a red alarm output value. If we max it out again, you can see our peak here of what it's seeing as the table. You can teach any distance as a 0 position. So here you can see I've got the sensor set as the table around 250 mil. The sensor reads it as 249.5 mil. If I want this value to actually read as 0, all I have to do is press the teach current distance, and you can see now it's set as our 0 point here. Okay, so now we can move into setting up the outputs. So we've set up the measuring range where we're interested to measure from. Now we can set up the outputs. So the sensor, as described, has got analog outputs and switching outputs. If I introduce a target underneath the sensor, you'll see that that card roughly measures 0.8 of a mil. So you can see the measurement jumps from 0.03 actually up to 0.9, minus 0.9. So yeah, around 0.9 of a mil is the thickness of the card there. If I now put in something with a bit more height in, you can see the measurement goes up to 15 mil versus the table where we set our 0 point. And this information here tells us where that 0 point is in the total range. Again, if I put something shiny in, like this metal bracket here, it's saying that sitting off the table it's around 3 mil, 2.8 mil, for example. Okay, so now we have that in context as what we can measure, we can set switch points, either a point switch point to say that if the sensor reaches a certain height, then please turn on. If you can also choose a window point where it says, now it's good between a certain region, and if it's too high then turn off, if it's too low then turn off. We can do that sort of thing as well. So you got point and window switch modes. So let's quickly just set that up. So if, for example, we set our target here, so the card and the target there is giving us 15 mil. If I want to, I can set that as my 0 point here, and then on the outputs I can say, right, as soon as I have reached a certain number of mil above that or below that, I can switch by either having it set as standard or set as inverted. So let's say, actually, let's put our target in there and set that as our 0 point. And then say that our switch point is anything that is half a mil higher than that. And let's zoom in so you can see that actually taking place there. Okay, so let's now introduce the card again. You can see the switch output here, and the switch LED on the sensor is currently off. If I now introduce the card, the output turns on, and also the output LED turns on the software, because the measurement is 0.9 of a mil higher than our 0 point. Take it away, and there we go, we're practically down to 0 again. The output light has gone off on the sensor, and also it's gone off here on the web server. So that's how easy it can be to set up a simple high-low switch point. If you wish to do a window point, very similar again, you can either scroll where you want the switch points to be, or type them in. So the far point, say, is 2 mil, for example, and the near point, say, is minus 0.5 mil. So let's try that again. If I now introduce my card, you see the output's on, saying it's good because the current measured value is good. If I put my card in, you can see the output has gone off because it's no longer in the good region. If I take it away, there you can see the output's back on again. And now if I take the part away, you can see the measurement is 14 mil difference, actually out of shot. And also the output's gone off here. Let's introduce the target back in again, and there we go, and we're back on again. And let's just zoom in into that area. There you can see our measurement line, where we set our tolerances. And again, if you want to put physical targets in and set them around that, you can do that, because that's where the measurement value comes into play. So if I want to say that that is currently too low, I could set the target anywhere between there for high and low. So regarding the analog output of the sensor, you can set it to maximum range over the sensor. So in this case, where I set the table to 0 was at 234 mil, and if I press set to max, the farthest it will be from the sensor is 184 mil, and the closest is 16 mil. So it's automatically set that as our maximum. If I then put in my target, you'll see where that lies. There we go. And so we can now, if we want to scale it over a smaller region, we can do that by either typing in the value that we require the range to be over, or by narrowing the field of view of where we wish to take our measurements. And you can see if I press set to max, it will automatically do it over that range. Or if I want to say right from 30 mil above our 0 point to 10 mil below it, scale it over that region here. You can do that. And of course, as mentioned previously, you can decide whether you want it to be 0 to 5 volts, 0 to 10 volts, 4 to 20 milliamp, or to 2 to 10 milliamps. And you can also invert that so that the near is this value and the far is that value, or vice versa. So let's investigate this Windows switch point just a little bit more. As you can see, I've set up my workpiece here with a card underneath it and set that as my 0 point here. And we know the card thickness is around 0.8, 0.9 of a millimeter. So if I wanted to detect whether there was one above it, one missing, etc., I could set switch points to give us pass or fail for far and close. So in this case, we go to window mode here and we say, right, anything, for example, 0.5 of a mil in distance difference and minus 0.5 of a mil distance difference above and below the product, give me an output for. And of course, we need to change our hysteresis to make this a little bit more accurate. And this can be down to anywhere as 0.1 of a mil. Oh, there we go. Okay, and now you can see that window above and below. And of course, you can change those manually as I described before. Okay, so now if I look at the outputs, you can see it's in the good region. So the output is on here, on the web server, and also on the sensor there. So let's take it away. So if it's half a mil lower, you can see the output goes off on the sensor, and also the LED goes off here. So let's reintroduce it again. There we go, the output's on, it's in the good region, it's measuring okay. Output's on here. Then if I introduce another thickness, so it's too high now, it's out of tolerance by too high, you can see, oh, I'm outside of my measuring range, which is why that has happened. Let's go back in there, and you can see now that we're underneath our set point for low point, and so the output has gone off on the sensor and off there. So let's go through that again. Scenario 1. Just the block on its own. With one card underneath. it's in the good range. With 2 cards, it's too high, and so the measurement is too far away. And then again, with no cards there at all. Output off, out of range, not visible, as you can see here. Okay, so now let's investigate just the single point switch point. So in the switch point area here, just make sure it's clicked as point, and now we can set a tolerance of output where we want the sensor to switch. So let's just zoom in around the beam spot itself where the measurement is. So currently I've set the switch point at 0.5 mil. It could be anything, 1 mil, 2 mil, 3 mil, whatever you require. You can either type it in there and you can see the bar move, or you can drag the bar up and down to where you wish and the value follows it. You can see here the value follows it. And so, for example, if we wanted to make sure that a plate was fitted like so, and we wanted to have an output for it on the fixture, or a very thin washer or something else, or the part was placed at the correct height off the fixture or off a datum point, we can do it for very small thicknesses, so even under a mil. So let's set it up for example. So we've set our workpiece here as our 0 point. We can say, right, once say this washer or something is fitted, it's a 0.5 mil higher. So we can set our switch point to say, right, should be 0.5 mil higher. And let's see that that is correct. So there we go here. And you can see our output's turned on, the output's turned on the sensor here. And you can see where it is here. Let's zoom in to see that a little bit better. That's where our switch point bar is. That's what our active measurement is. If I now take that away again, and it's just on the workpiece, the output's gone off. The LED has gone off here as well. And you can see the measurement that we're taking here and the value there. Reintroduce again. And you can see the output turns on, the value there, and the output is on the sensor there. If you've got something that's got a little bit more thickness, of course, let's take that away. Something like a shiny metal plate, you want to make sure it's fitted on. You can see the value difference there. Let's just zoom in on that area there so you can see a little bit better. So the switch point is at 0.5 mil. Where the piece is 2 mil higher. If I want to change that to 1 mil or 1.5 mil, you can see that drop that line there where the output is. If I take away the plate, you can see the output goes off here and off on the sensor, and then when it's fitted again, the output turns on the sensor and also here on the web server indicator. Okay, so just a few final points to go through on the actual web server element of the sensor. You can save the parameters of the sensor. You've got 3 setups that you can save. So if I want to save this setup here, I just select it and click save. If I've got some settings already set up and I've saved the files, I can import them or even export any of these setups to an external location or import them from an external location. Okay, let's go to the device configuration tab here, and this is where you've got all of the sensor information. So it enables you to see the exact sensor type, the serial number, the production code, and what the network information is here. So with respect to the network, what is the IP address, the subnet mask, or also the gateway. And if you're using a dynamic setup, whether you want that on or off. And so it allows you to connect to obviously your own Ethernet switch and what address you wish the sensor to have. This is where you input that information and save the configuration basically. And then just some other of the time synchronization and the process interface selectables that you've got here. So out of the box, you've got Profinet, Modbus TCP and OPC UA enabled and UDP streaming off. But if you want the UDP streaming, of course, just select it as on, the IP address and the port that you're using for it. The parameters that you've got set up are also stored on the sensor, and you can see what the individual characteristics and aspects are of that setup. So this is the one that we just set up now, and you can see all the information with regards to it. You can password protect the sensor itself, and you also, if there are new web interfaces to be uploaded, you can do that at this point here. Reset the settings and also do a full factory reset of the sensor there. If we go back to monitoring here, you can see the application that we just set up, and you can see the time graph for it there. And you can see our measurements on and off as they go. So I just wanted to mention that as well as the web server version of the OM70, there is the standard version of the sensor, which I have connected here. So not the easy setup that you've got via the web server, but all of the settings can be set up on the sensor itself with its display, and you can see it's measuring 249 mil there. I put my block in again, 236 mil, my bracket in, a couple of mil difference there, and then of course my white card in there, down to 248. So you've got the physical digital switches on off, window mode and point mode, and also the analog output via the sensor itself. Just a few more settings are available via the web server version here. The only downside is you lose the display, but all the easy setup is done through the web interface.